Hi, and welcome to lesson 3.2, and here we're going to talk about the effects and the effects window and how we can use effects. So in this video we're going to talk about externality effects in LEAP. So effects could be pollution, CO2 emissions, and generally things that we don't want coming out of our system, but absolutely is happening. So here we will be very practical about it and talk about how we can add effects, how we can see the results of our effects between scenarios, and also looking at the effects window, which we actually will start with. So the effects is pollution and other externalities. That's the one thing to note. So they can be encompass both NOx, SOx, CO2, COO, PM2.5, PM10, and all other pollutants, both that are granular physical or gaseous in nature. The other thing in LEAP, or for that matter also in real life, is that it is very important that we add the effects at the point of the pollution. What is meant by that is if we have a system like here, so in the central point here we are saying that we have a PHEV vehicle, so it runs both on electricity and on gasoline, and we are interested in finding the different pollutants from this. So if you take the full system from resources to end-use demand to and further on, we have to find out where is the pollution actually occurring. So on the electricity side, here we're saying it's produced by coal. I tried to represent. So we have both the mining of the coal. So we put in it further. While we're on the oil side, we have the oil extraction. So this is the, what do you call that? Well, offshore oil extraction or onshore oil extraction. And here we will have the power plant that converts from coal to electricity, which is then the electricity is the product that gets delivered to the electricity side of this vehicle. And here in transformation sector, we go from crude to a different product that we can use directly in the car, usually gasoline, or here we call it gas. So the question is, where is the pollutant happening? On the electricity side, well, we have the end product is the consumption of electricity, but the consumption of electricity is clean. So that's not why we have the pollution. While we do have some different stages of losses and therefore pollutants throughout the system with extraction and so on, on the electricity side, the pollution that's happening on the power plant. So that's the PP is the real pollutant in the systems. At least when we're talking about fossil electricity. Well, for the gasoline, it's actually different. We have some few losses, of course, in the extraction of oil and in the transformation of oil, but the actual real happening of pollutants is happening in the vehicle itself. So that's the consumption of the gas consumption that really shows this pollutant. So if you were to model that in LEAP, it is important that for the electricity side, well, we don't want to put the pollutant on the electricity itself. No, we want to put it exactly on the point of pollution, which is in power plants in this case. But for something like oil extraction, we might have some pollutants, some very, very few percent that depends on the transformation and the losses, which is generally pretty efficient, but here it's by far the most of the pollution is happening on the vehicle side, more than 90%. So that's also what we have to look at. So we have to be very, very conscious on where we put our pollutants, and it only fits to that part of the full fuel chain or fuel stream. So the first thing we have to do is we have to go into our settings window, which I am not going the full way now because you should know where it is by now. And we have to add a few things. first off, we probably want to add the transformation of resources. So we have transformation and resources on the fuels. And then we need to add the different forms of energy effects. The most important one in this case is just generally energy effects. The other ones are more something we can add on, and we will be concentrating on energy effects for now. We will later be talking about more complex effects, which is the IVC, but that will come in 3.4, I think, in one of the later videos at least. So then now we have that enabled. How do we actually use it? Well, we can add one effect. We have to add that. That's worth noticing. We have to add it on the technology itself. So it has to be added to a technology, and that can of course be both a normal technology, a total technology, energy intensity technology, or a technology that's start turnover. So that doesn't really matter much with this, but it has to be added on the technology itself. We simply do that by right-clicking the technology if you have the other thing added in settings, and then we can add an effect directly. So in this case, I'm adding carbon dioxide, CO2, and now I can set in my value of my emissions of the CO2 for this technology. Of course, this should be both done now. I did it in a scenario here in the Freedonia model, but of course that should be done probably in current accounts, because it has a tendency not to change much. The pollution of an engine does not change really that much, but other than the fact that the engine gets more efficient. So the pollutant per energy used is not the biggest factor here. So it plays well to do it in current accounts. But as you saw here, I just added CO2 for a natural gas stove, which is a pretty general technology. And if I wanted to, if I wasn't just interested in climate change only, then I maybe also want to add PM2.5, PM10, SOx, NOx, and a bunch of other things. But getting data on that can, for one, be pretty difficult. And the other thing is we have to fill out these, and we have to do it for each and every technology that there is that we can't just copy. And that means in quite a lot of models, these are effects we have to add. We are maybe talking in the hundreds. So that takes a long time, and we may want to see if we can make that more efficient. So Leap has solved that. So actually we can add multiple effects using the TED, which is a technology database. We have briefly touched on this database before, I think, in lesson 2. So the way we do that is we again click on our technology. We still have to do it on technology, and we just use the add multiple effects. Now it opens the TED database, and we can try to see if we can look for something that fits where we are trying to do. Actually, and TED and Leap will suggest one first, but we can see in this case we didn't quite find one, so we just used IPCC Tier 1, which is just for natural gas emissions. So we didn't find one for the specific product, so we're going a little more generalized. We can always change the numbers to be more specific. Now that we have done that, you see we have a little plus sign, and now we have all the different effects that we want. And even better than that, I think we'll go to that in a second, we can see we actually have a pre-filled a model for that. So it already knows how much carbon dioxide, carbon monoxide, and different things that comes from you burning natural gas. In this case, you can see there's actually no PM pollution, but that can be added as well manually afterwards. You are welcome to do that. And it does have those in multiple of the different versions. So it's a really, really efficient way of doing that, and we can just start adding that. Now, as a more practical note, you can see, again, just like with the gasoline example we have here, where we do pollute with the natural gas stove, and that actually is quite bad because it's probably indoors as well. While here in the electrical stoves, we have no pollution on the end use side. So that's worthy to note, that you have to only, while you do have to do it on technology, you should do it on the technology that fits with the endpoint. The pollution for electricity can be done in transformation, and you can do that just as easily. And you probably even have more data for that in the different electricity production methods, but that's where that belongs. That also means in terms of scenario, we can really start to look at where we have the most pollution and maybe even local pollution if we go a little bit more advanced, but that we will go to that later in a different video in this lesson. Before we go on to look at the results, we just want to take a bit of a peek on the effects window. And in Leaf, it has its own menu in effects, and we'll just take a look at that. So the effects window, looking like the fuel window and other windows as well, is a little bit special because you have to just define different things here that are not quite the same method of everything. So for instance, you can see that we have all of our pollutants that are in our segment, oral effects. We have some formula, which is used for abbreviations, which is quite nice. And then we have the categories. So we have more than one effect. So you can see we have global warming effects or greenhouse gas effects for the different effects we have. And then we have some that are local air pollutants. That's also where you would find we can add in other models PM2, PM2.5, so on. These are the ones that are that also do that, attribute to that. And then we have the CF gases, which are the gases that cause holes in the ozone layer. So those different categories we do have. And then, of course, you can see it doesn't actually say much other than the global warming potential. And that's because there is a translation layer between carbon dioxide, methane, and so other, what their global warming potential is, and in what yearly, how many years the global warming potential is. So that is listed in this table, and it does that for all of the different the pollutants. So you can see, that's standardized as C2 equivalents. So you can see that some of these are far worse than we have for CO2, but they're also quite a lot rarer, which is nice. It does not say much other like PM2.5 effects because that's calculated differently and quite a lot more complicated. Again, we'll get to that when we get to the IBC calculator in a few videos. So we will just take a quick look at how to showcase results of the effects. So we'll just calculate. It's quite quick to calculate. It doesn't add much to the calculation time of the model. And here we can see we also have cost that we showcase, but we in the environment we find everything related to pollutants. And then here we just have global warming potentials. So we can see that for the different scenarios and where it comes from in our branch structure. We can show the different things. Here I'm just choosing carbon dioxide. We can also show how much methane we have in our system. But the best thing we can do and what is most relevant for reporting is how much we avoid compared to a baseline scenario. So that's what we see here, where you can see like, okay, we actually reduce by a certain percentage that can be quite large. And that's usually what we're trying to go for. And that's and you can still see where the main things pollution is happening in our main scenario that we're looking at. We have a few ways of looking at that, so we'll just look at another effects results or method to look at that. When we look at the major reporting, we usually only get to see where or how much the projection of our emissions differentiate between our different scenarios, but actually we can also do more of a deep dive, which is very useful for policy analysis and change, and we will show you that right here. So here you can see we have the macro level where we can see between scenarios. We can just look at the one scenario we're in this case mitigation, and then we can go and see deep diving where are we actually experiencing our emissions. And we can do that the same way as energy consumption. So we can see we have quite a lot in this case of our emissions coming from especially vehicles. And we can also use that to see how much do we actually save in different sectors. So again, here on the full demand sector, we are avoiding very little. If you instead look at the transformation sector, you can see a lot of things that are happening there. And that's probably because we are using a lot of renewable energy to produce our electricity, and therefore we avoid quite a lot of emissions. In that case, we can see we can do more of a deep dive. We could also go more into to the different processes. See, is it because we avoid using coal, or is it the avoidance high energy efficiencies, or what is actually the cause for this emission change? But if we're looking at a system like this, we maybe would have a natural inclination to look at maybe we should look at road vehicles more in the next iteration of our model forming, because that's where we have the most potential on the demand side and maybe to do something. So that is quite a good method to find out where you can form the best bang for the buck emissions policies. Now, I was saying that that when you're using the avoided versus another scenario, you cannot actually see where you are avoiding your emissions. What you should do instead here is what I have done here. This is the comparison, not avoidance, just comparative between two models. So we can now here see that how much we have. I actually think I will avoid it. It's not avoided. It's comparative. So I avoided. So I said, like, how much how much does the mitigation scenario pollute more than the baseline scenario for in all fuels for all greenhouse gases? And there we can go and have a deep dive, and we can see that in no years we are having a larger emissions compared to the baseline, but we can also see like the vast majority of what we do in all through the period is on the transformation side, with only a little bit in non-energy, that's agriculture in this case, and or on the demand side. So not much is done. So maybe we should take a further look on the demand side. To keep this simple, I haven't done it, but you could also turn up the levels you're looking at, and then have a more granular look in exactly where do we save our emissions and where do we not, which is also as important.